For notes number 8, we're going to continue practicing our trig ratios, finding missing sides of right triangles. So for the warm-up, today you're actually going to be going to a Kahoot game, and you're going to go to kahoot.it and type in that code. Make sure you write your name so that I know who is competing, and you can get your credit for the game. It's just a quick review of key vocab for this unit. So our trig ratios, if you remember, there's a saying in order to remember it. It's called SOHCAHTOA. So SOHCAHTOA. And this is used to remember what sine, cosine, and tangent stand for. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then just a quick reminder, sine, cosine, and tangent always have to have an angle attached to them. If you just see the word sine, this is abbreviated for sine, S-I-N-E, it's meaningless unless it has a variable to represent an angle or the actual angle degrees. So in this first example, we're asked to write the sine, cosine, and tangent of a given reference angle. And in this picture, we're given all three sides, 12, 16, and 20. So if they ask us to find the sine of angle D or the cosine of angle D or tangent of angle D, they're saying to use D as your reference angle. So we're going to relate all three of these to the reference angle D. And I'm already going to label my opposite, hypotenuse, and adjacent in relation to angle D so that the next three equations can be filled out quickly. So what is directly across the reference angle? 16. So there's my opposite. The longest side of the triangle, hypotenuse, is 20, and then the adjacent would be the 12. So for the next three equations, we're just using the definition of sine, cosine, and tangent. So sine is defined as opposite, which is 16, over hypotenuse, which is 20. And then it does say to write this as a reduced fraction, so we're going to divide by a common factor, divide by 4, so I get 4/5. For the next one, cosine is defined as adjacent over hypotenuse, so the adjacent is 12, hypotenuse is 20. Same process, reduce, divide by a common factor, which is 4, and you would get 3/5. For tangent, tangent is defined as opposite over adjacent, so 16 is your opposite, adjacent is 12, and again, divide by a common factor, so we're dividing by 4 again, and we get 4/3. So for this next part, our reference angle changes. Instead of angle D, it goes, they're using angle E. So I'm gonna redraw our picture so I can label O, A, and H. All right, so I erased the picture here. So now our reference angle is angle E. So I'm gonna relabel my O, A, and H according to angle E. So the opposite side is now the 12. The hypotenuse never changes because it's always the longest side of the right triangle, but the adjacent is now the 16. So filling these next three out, exactly what we did with the previous, using the definition of sine. Sine is opposite over hypotenuse, so the opposite is 12, hypotenuse is 20, and then divide by a common factor. We're dividing by 4, and we get 3/5. For cosine, cosine is defined as adjacent over hypotenuse. The adjacent is 16, the hypotenuse is 20, divide by a common factor, so divide by 4, and we get 4/5. Lastly, tangent is defined as opposite over adjacent. The opposite's 12, the adjacent is 16, divide by that common factor again, and we get 3/4. So for the next three examples, all we're doing is finding a missing side of a right triangle using one of our three trig ratios. So the very first thing is to locate the reference angle, which is 36 degrees, and you're going to label your opposite, hypotenuse, and adjacent, but again, only labeling two of those because the blank side does not get a label. So I'm going to check for the opposite first, going directly across the reference angle. This would be my opposite side, but because it's completely blank, I'm not going to label anything there. Next, I'm going to locate the hypotenuse, which is across the 90-degree angle. So my variable x is my hypotenuse, and therefore the 19 is my adjacent side. So sine is defined as opposite over hypotenuse. cosine is adjacent hypotenuse, tangent is opposite over adjacent. In my picture, I have an A and an H labeled, so the ratio that I'm using, this equation, is going to be the cosine ratio. If I have to estimate my answer, I notice that we're trying to find the hypotenuse, which has to be the longest side, and 19 is the only side length given, so I know that my answer has to be bigger than 19 because I'm finding the hypotenuse. So if I plug in to this equation from the picture, cosine, my reference angle is 36 degrees, and that's equal to, my adjacent is 19, and my hypotenuse is x. So make the left side a fraction by putting a 1 under it, and then cross multiply. So 19 times 1 is 19, and that's equal to cosine of 36 times x is just cosine 36 times x, or I'm going to write the x in front, x times cosine of 36. From here, we still have to isolate the x, so the opposite of multiplying by cosine 36 would be dividing both sides by cosine 36. So I do have x isolated, but I do have to type this into a calculator. So to type this in and round to the nearest tenth, I would type in 19 divided by 36 cosine equals, and I get approximately 23.5 rounded to the nearest tenth. And that checks out because it's larger than 19. So again, to type in this fraction right here, read it top to bottom, 19 divided by 36 cosine equals. For number 3, the reference angle is 75 degrees, and so let's identify our opposite hypotenuse adjacent. So directly across the 75 degrees is my opposite, so 12 is my opposite. The hypotenuse is always across the 90, and if I look across the 90, it's completely blank, so we're not going to label anything for hypotenuse, and then therefore x would be my adjacent. Shifting over to which ratio I'm using, sine is opposite over hypotenuse, cosine is adjacent hypotenuse, tangent is opposite adjacent. So in my picture, I notice that O and A are labeled, so I'm going to be using this equation in order to find the missing side. So if I look at my picture, I notice that I'm looking for x, which is shorter than 12, so my answer should be less than 12. So if I plug in from the picture, I would have tangent, my reference angle is 75 degrees, and that's equal to the opposite, which is 12, and the adjacent, which is x. So I'm going to make the left side a fraction by putting a 1 under and cross multiply. 1 times 12 is 12, and that's equal to tangent is 75 times x is just tangent is 75 times x, or x times the tangent is 75. One last step to isolate the x, the opposite of multiplying by tangent is 75 is dividing by tangent is 75. So here's what x is equal to. We have to type this into a calculator and round to the nearest tenth. So I would type in 12 divided by 75 tangent equals, and I get approximately 3.2 if you round to the nearest tenth. For number 4, my reference angle is 57 degrees, so let's label our O, H, and A. So the opposite, directly across the reference angle, there's a variable there, so that would be my opposite. The hypotenuse is across the 90, there's a 10.8 there, so this is my hypotenuse, and we're completely finished with labeling. So sine is defined as opposite over hypotenuse, cosine is adjacent hypotenuse, tangent is opposite adjacent. So if I look at my picture, I notice that there's an O and an H, so that would be using the sine equation. So in my picture, I'm given the 10.8, and that's the hypotenuse, and I'm finding the missing side length x. So since 10.8 has to be the longest side, since it's a hypotenuse, my answer should be less than 10.8. So plugging in from the picture. So sine, the reference angle is 57 degrees, and that's equal to the opposite, which is x, hypotenuse, which is 10.8. So I'm going to make the left side a fraction by putting a 1 under and then cross multiplying. 1 times x is x, and that's equal to sine of 57 times 10.8 is just sine of 57 times 10.8. Or you could write 10.8 times sine of 57. So x is completely isolated, so I'm ready to type this into a calculator. So to press sine of 57, I have to press the reference angle first. So hit 57, then sine times 10.8 equals, and I get approximately 9.1 if you round to the nearest tenth. And that is definitely smaller than 10.8. For the last two examples, we're going to practice how to factor or convert forms. So if you remember down at the bottom here, I have an example of factored form, which is parenthesis form, and then expanded form, meaning no parentheses. So if you're asked to factor something, there's 3 different ways to factor. One is finding a common factor, some number that divides all of the terms. Method 2 only works if it has 2 terms. There's a minus sign in between them, and you have to be able to take the square root of both of the terms. The third method has to have 3 terms in the form of x squared x and then a constant, and this is a method where you multiply the first and last. So a times c, you're trying to find what multiplies to the product of a times c and at the same time adds to the middle number b. So the very first thing I'm going to do is go down the list here, method 1, 2, and 3. So method 1, is there a number that divides 5 and 20? And in fact there is. The biggest number that divides 5 and 20 would be a 5. So I'm going to factor out a 5, and then it's kind of like distributing backwards. You're saying 5 times what would get you back to 5x squared? Well, 5 times x squared, bring down the minus sign, and then 5 times what would get you 20? Well, 5 times 4. So we use method 1, so that's complete. Once you're finished with the method, you do have to check what's left inside the parentheses to see if you could factor that further. So the only options left are method 2 and method 3, and I know that method 3 would not apply because it has to have 3 terms for method 3. So I'm checking if this is the difference of squares. First, is there a minus sign in between the 2 terms? Yes. Can you take the square root of both terms? The square root of x is x, and the square root of 4 is 2. So in fact, this is the difference of squares. So for difference of squares, you open up 2 sets of parentheses. You alternate the signs, one's a plus and one's a minus. And then the first term, which was x squared, gets split in the front spots. X squared is x times x. And then the back term, which is 4, gets split in the back spots of each parenthesis. So the square root of 4 is 2. So 2 times 2 would give you the 4. And then the 5 that you factored out in the very beginning, that just goes in the very front. So this is completely factored. The very last example is asked to solve a quadratic equation. How do I know that this is quadratic? Whenever your highest term is x squared, that would be quadratic. So these are the 3 ways to solve quadratics. Option number 1, if you can do it, you're going to factor the quadratic and then use the zero product property. Option number 2 is isolate x squared. Move everything to one side of the equation and isolate the x. Option number 3 is quadratic formula. However, all 3 of these have to have something true. The equation has to be equal to 0. So if I look at this equation, I notice that it's not equal to 0, it's equal to 48. However, I can move the 48 over to the left side, so all the terms are on the same side, so that the equation is equal to 0. So to move a term, you just do the opposite sign, so subtract 48 from both sides. So now it's equal to 0 on the right side, and then I can't combine the 48 that I moved over with the other 2 terms, so I'm just going to write it in standard form, highest degree to lowest, so x squared minus 2x minus 48 is now equal to 0. So we made sure it's equal to 0. So isolate x squared method only works if you have 2 terms, so this is not going to be an option. So the only options we have are factoring, if you can factor it, or use the quadratic formula, which works every time. So if I were trying to factor this, I would first check if there's a GCF, a number that divides 1, 2, and 48, besides 1, and the answer is no. So GCF does not work. Difference of squares has to have 2 terms, and my polynomial on the left side has 3, so that's not going to work. So method 3 trinomials, it is a trinomial, works if you could find a factor pair that fills in this chart. So you're saying what multiplies to the back number, which is negative 48, and at the same time adds to negative 2. So again, multiplies to 48, and then at the same time adds or sums to negative 2. So if my product's negative, there has to be one negative. So if I think of some factors of 48, you could just take 48 and divide by 2 in a calculator and keep going from there. Divide by 2, divide by 3, divide by 4, and so forth. I think there is a factor pair. I would say 8 and 6 would work. So 8 would have to be negative and the 6 positive. That multiplies to negative 48, and at the same time, if you take negative 8 and add 6 to that, you get negative 2. So for trinomials, method 3, the factoring method we used, you set up double parentheses, x squared splits as x and x, and then my two factors would be, in any order, negative 8 and then positive 6. So I completed the factoring part, but to find the two solutions, you still have to apply the zero product property. So the zero product property says if I am multiplying these two values together and my answer is 0, then one of these has to be 0. So either x minus 8 has to be equal to 0, or x plus 6 has to be equal to 0. And if you remember from class when we did this first semester, we said the easiest way to find the two solutions is to just flip the signs, because if you add 8 to both sides, you would get x is positive 8, and if you subtract 6 from both sides, you would get x is negative 6. So my two solutions would be positive 8 and then negative 6.